This lecture is about action potential. In a neuron, or nerve cell, an action potential refers to an electrical impulse, which travels through axon. To understand the action potential, first we should know about the resting membrane potential, which is about -70 mV. -70 is the charge difference between the two sides of the cell membrane. In the cell membrane we have different structures such as sodium-potassium pump, and different channels for these two ions. First, let's take a look at sodium-potassium pump. Sodium-potassium pump is a dynamic active pump which can transfer 3 sodium ions out of the cell, in exchange of transferring 2 potassium ion into the cell. By this we have a higher concentration of positive ions outside the cell, which remains the resting potential in -70 mV. We can record the changes in membrane potential by monitoring the voltage differences during the time. As you see, during the resting membrane potential, the voltage difference is maintained on -70 due to the act of the pump. Receiving a stimulus by receptor opens some sodium channels in dendrites. This will let the influx of sodium, and moves the resting potential toward -60. But it is not enough for triggering the action potential. If the stimulus gets stronger, more receptors will get active and more sodium will arrive into the cell. This changes the membrane potential to -50, or threshold potential, which is enough for triggering the action potential. At this point, sodium channels open and sodium ions rush into the cell due to electrochemical gradient difference, and around this channel, the membrane potential reaches to +40. We call it depolarization. This local depolarization opens neighbor potassium channels, and potassium ions rush outside the cell and membrane potential back toward the resting potential. This process is known as repolarization. Repolarization can overshoot and cause hyperpolarization, and membrane potential can reach to -90 before back to the resting potential. The sodium-potassium pumps correct the concentration of ions, again as high sodium concentration outside the membrane and high potassium concentration inside the cell. Depolarization is also leading to opening of the neighbor voltage-gated sodium channel and moving the depolarization along the membrane.